Alright, this is lesson 6. This is solving systems by graphing. So it says a system of equations is a collection of two or more equations. So by looking at these two equations together, that would be a system. Notice they have the same exact variables. They have an x and a y with them. Okay? So it says the equations y equals 5x and y equals 30 plus 2x together are a system of equations. The solution to this system is 10, 50, because the ordered pair is a solution to both equations. Meaning, if I plug 10 in for x on both of these, my y is both going to come out to be 50, and they prove that here. They plug the 10 in, 10 times 5 is 50, 10 times 2 is 20, plus 30 is 50. So that's one number, or one solution, that works. If I would plug in a different number for x, it's not going to work. So 5 times 1 is 5. Here, 1 times 2 is 2, plus 30 is 32. So 1 wouldn't come out to be the same y. A solution is when you have the same x coming out to be the same y for two different equations. Okay? Says, one way to solve a system of equations is to graph the equations on the same coordinate plane. The coordinates of the point where the graphs intersect is the solution to the system of equations. Now, I kind of cheated for today, and I took the notes that were already completed, so I'm just going to be talking through the parts that are already done rather than filling them out as we go, because this is kind of a longer lesson today. So our first example, we have y equals x. So that means my slope is 1. That means my y-intercept is 0. So I begin at 0, and my slope is 1. That means I rise 1, run 1, rise 1, run 1, rise 1, run 1. Okay? So that's the blue line here. Then for the second line, my y-intercept, my begin is at 4, and my slope is -3. That means down 3, right 1, down 3, right 1, down 3, right 1. Okay? When you look at these two, they meet at this point. This is the solution. If I put in 1 for my x value on each of them, I'm going to get 1 for my y value on each of them. Okay, so where they cross, that's my solution. On this example, again, we're going to graph them. So y equals x plus 2. I begin at positive 2. My slope is 1. So rise 1, run 1, rise 1, run 1, rise 1, run 1. On this one, I'm going to begin at -4. My slope is -2. That's really a -2 over 1. That's down to right 1, down to right 1, down to right 1. Once you extend your lines in both directions, you'll find they cross right here. That solution is at -2, 0. Meaning if I plug -2 in, I'll get 0 on both of them. -2 plus 2 is 0. -2 times -2 is 4. Minus 4 is 0. Okay? Here are two more examples. So where I begin is -1. My slope is 1. That means a rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. The second one, my begin is -2. My slope is 2. That's a rise 2, run 1. So up to right 1, up to right 1, up to right 1. They cross at this point. That point is 1, 0. This one's a little bit different. Okay, first of all, on this blue equation here, my intercept is 0. There was no plus or minus anything, so my b or my y-intercept is 0. That's where I begin. My slope is 2, so just like this one, that's a rise 2, run 1, rise 2, run 1. Okay? This next one, it was not in y equals mx plus b form, so you have a couple options of how to graph that one. You can, first of all, solve for y. So to solve for y, I would subtract x on both sides. If I do that, let me show you. So x plus y equals 9. If I subtract x on both sides, those would cancel. And on the other side, it would be -x plus 9. Remember, constants always go last. They are not like terms. I can't combine them. So that's where I got this. So my begin is at 9. My slope is -1. Down 1, right 1, down 1, right 1, down 1, right 1. Okay? The other things you could do is you could come up with points. You could say, okay, if x is 4, y has to be 5. If x is 5, y has to be 4. If x is 9, y has to be 0. And things like that to come up with a few points to graph and then make your line from those points. The last option you have is you know how to find your x and y intercept. So for my x-intercept, I plug 0 in for y and solve. For my y-intercept, I plug 0 in for x and solved, and I can make my line. So you can really put your graph, you could graph by any of these ways as long as you get the graph of both of the lines so you can see what the solution is. Now, there are also story problems today where you have to write the system based off the story problems. So the first one says Marjorie and Brian are selling magazine subscriptions. Marjorie sells 3 times as many subscriptions as Brian. Brian sells 12 fewer subscriptions than Marjorie. So if we're looking at this, we have Marjorie sells 3 times as many as Brian. So I take Brian's, multiply it by 3, and that's how many Marjorie sells. The second sentence, notice, is going to be a different equation. So don't put the 3 in that second equation. That was from its own equation. So Brian sells 12 fewer subscriptions than Marjorie. So again, if I take Brian's and I add 12 to it, that's going to be how many Marjorie sells. Once you have your equations, you can graph them. So here my begin is at 0. My slope is 3 over 1, so rise 3, run 1, up 3, right 1, up 3, right 1. Here I begin at 12. My slope is 1, up 1, right 1, up 1, right 1. Now notice, I'm not going up with the boxes. I'm going up how much it would actually be. This is sometimes really hard to tell. So what we did over here is we ended up finding some points that we knew. So if I plug 0 in for x, my y is 0. If I plug in 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 would give me 12. And once I found a point that I knew was right on the line, this is 4, 12, then I just made my line from that. I did the same thing over here, okay, until I had my 2 different lines and I found this is where they cross. Now, it looks like it's at 6, 18, but to be sure, what I can do is I can plug the 6 back in. 6 times 3 is 18, and 6 plus 12 is 18. So I know for certain that 6, 18 is my solution on this one. Here's another example. It says a doctor's office has twice as many new patients as existing patients. The number of new patients is 22 more than the number of existing patients. So those are 2 different equations there from the 2 different sentences. The first thing you have to do is figure out what you want your x and y to be. Okay? So the 2 things we're discussing are new patients and existing patients. I tend to always put the biggest number as my y. I just think it's easier to write the equations when you're following with the y as your biggest number. Okay? So twice as many new patients as existing. So that means I have to take the existing and double it to get my new. So take the existing times 2, that gets my new. The second part says the number of new patients is 22 more than the number of existing. So the existing patients plus 22 gives me that amount of new patients. Then I take those 2 and I graph them. Again, you could do this and have your intercepts and use your slope as your rise over run, or you could find points. Remember, the other thing you could do is find your x and y intercept for them. Now, that's going to be a little bit trickier on these because notice we don't, on the blue, we're not really paying attention to our x-intercept. So when you do that, sometimes when it's just one quadrant, that won't work very well. So that's why we left that one out on this example here. Okay? But you can always plug in points. 0 times 2 is 0. 2 times 2 gives me a y of 4. 4 times 2 gives me a y of 8. Here's 0 plus 22 gives me a y of 22. 2 plus 22 gives me a y of 24. 4 plus 22 gives me a y of 26. And then I plotted my points. I found that this is where they cross. So when it says explain what it means, that's telling you you have to explain that the 22 means existing patients and the 44 means new patients. So if it says explain, it's basically saying look at your x-axis, look at your y-axis, what do they both stand for? Here's the last story problem we have to go over. It says one CD Club A charges members $25 annual fee. After that, CDs cost $5 each. Another CD Club B has no annual fee and sells its members CDs for $7.50 each. So here's my equations. It's $25 annual fee plus $5 per CD. For Club B, there's no annual fee, but it's $7.50 per CD. We went ahead and graphed. Again, you can use your beginning point and how you move, or your y-intercept and your slope for your rise and run, okay? Or, like this one's kind of tricky, you might need to come up with points. 0 times 7.5 is 0. 2 times 7.5 is 15, so 215. Okay? Once you do that, you find where they cross. They cross at 10 CDs is $75. So when it asks how many CDs would you need to buy in a year for the clubs to cost the same, well, they both cost $75 when you buy 10 CDs. The next one says which club would be a better deal for customers buying $20 CDs. Well, when you look at this, you can kind of follow the slopes here. This one has a steeper slope, so that one's going to end up costing more if you extend it than the red one. The other thing you can think through is try plugging it in. You can take 20 times 750 and find out. You can take 20 times 5 plus 25 and figure it out and see which ones work better. Okay? The next one is just another example, except it's saying it's not always going to be solved for y. So in this example, we have y equals x minus 2, and we have x plus 3y equals 6. We need to get this in y equals mx plus b form. We already did one like that here, where I said we have a couple options. We can solve for y, we can do our y-intercepts, we can do our points. Okay? So in this one we ended up solving for y. When you do that, remember, if there is a coefficient, you have to divide each term by that amount. And then once you have the two, graph them and find your solution. The last part to it was that sometimes when you look at these, it's going to come out that they're parallel lines or that they're the same line. So notice here, on the red one, I have my intercept at 4, and my slope is 1. Rise 1, run 1, rise 1, run 1, rise 1, run 1. Okay? Here I have an intercept of 0 and a slope of 1. So again, rise 1, run, up 1, right 1, up 1, right 1. Since they're parallel lines will never meet, will never cross. That means they have no solution in common. There is no x value that I can plug in that's the same for the y. So one thing to notice for that is that's going to happen when the slope is the same, but the y-intercept is different. Okay? The next example is one where I can graph this equation. So my begin is at -1, my slope is rise 1, run 2, up 1, right 2, up 1, right 2. This other one, remember we have choices on how to solve. We can solve for y, so I subtract x on both sides. Don't forget keep that sign in front, so divide by -2 on all parts, and -1 divided by -2 is just 1 over 2, and 2 divided by -2 is a -1. So I could do it that way, or I could solve for my intercepts. So for my x-intercept, remember, I plug 0 in for y and solve. For my y-intercept, I plug in 0 for x and solve. And either way, I'm going to find that it's the exact same line. When it's the exact same line, that means there's infinitely many solutions. Infinitely many solutions. Okay? So they gave you one more example, just kind of showing that again, so you can look through those on your own, and then they kind of give you this diagram here that helps you to know if they intersect, that's one solution. If they're parallel, that's no solution. If they're the same line, that's infinitely many solutions. Okay? And notice, once again, parallel means same slope, different y-intercept. Same line would be same slope, same y-intercept. Okay? Let me know if you have any questions, and I'd be glad to help.